So finishing up some things that we have left to talk about with functions, we're basically going to look at two things here. One is going to be the domain of a function, and another is going to be what's known as the difference quotient, which is very, very important to know when you start to look at some different things involving formulas for when you take calculus next year. So a couple things about the domain of a function. Okay, so what we're basically looking at with domain, and you guys have done some different things in the past with domain and range back in Algebra 2, but what we're going to look at is what's known as the implied domain. An implied domain is when you examine the equation of a function and try to determine what are all the different possible values that you can substitute in for x that would get you some type of real answer for y. So the implied part of this comes in because the domain is not stated in the given question. It's something that you're going to have to figure out. So this bold at the bottom, hopefully this sort of clears up a lot of some of the confusion that sort of comes in with domain. But the domain of most functions is all real numbers. And if you've ever seen this symbol before, and I'm just going to kind of go all real numbers here, all real numbers. If you've ever seen this symbol before, okay, this is the symbol for all real numbers. And what all real numbers are basically all the numbers that go from negative infinity to positive infinity. So we're not talking about imaginary numbers, we're talking about real numbers. So the domain of most functions is all real numbers, but we're going to take a look at two examples when that is not the case. And here's the first one. So most functions, like we said, the domain is all real numbers, meaning most functions you can substitute any number you want in for x and still get some type of y value answer that's not imaginary and is not undefined. Well, here's an example where that's not the case. And you have f of x equals 1 over x squared minus 4. So one of the cases when the domain isn't just all real numbers is when you have a fraction with a variable in the denominator. And what we basically do anytime we have a fraction with a variable in the denominator and we want to know what the domain is, what we basically do is we take the denominator of the fraction. Let me sort of just erase these circles here for a moment. What we do to find out what the domain of this is, since it's not just all real numbers, okay, is we take the denominator of the fraction. I'm just going to swing this down here. And we say that x squared minus 4 in this case can't equal 0. And the reason we don't want it to equal 0 is because if the denominator equaled 0, then we would have a function that's undefined. So that would give us a value for y that was undefined, and that's not really what we're looking for here. So what I want to basically know is what values am I going to exclude from the domain in order to make it so the denominator doesn't equal 0. So if I go to solve this, now if you notice x squared minus 4, that's a difference of two squares. I can factor this. So I get something that looks like this. This would be x plus 2 and x minus 2. And if I set each of those parts equal to 0, x plus 2 equals 0 and x minus 2 equals 0, right, I get x is, or I should say, can equal 2. Sorry about that. X can equal 2 and x can equal negative 2. It could be anything else. I could substitute any other number that I wanted in for x right here. And if I did that, I would get some type of real answer for y. But if I were to put a 2 in for x here, that would make the denominator 0. That makes the function undefined. That I want to exclude from the domain, as well as negative 2. If I put a negative 2 in for x, that would also make the denominator equal to 0. So that would make the function undefined. So that would get excluded from the domain. So in terms of what I would state what the domain is for this, I would say the domain is, I'll just put this up here, the domain would be all real numbers except x can't be 2 x can't be negative 2. Any other number that I would substitute in for x would get me some kind of real answer for y. So that's one case when the domain is not all real numbers. Another case is this, and that's when you have a variable inside of a square root. So what we're looking at with the variable inside of the square root, so keep in mind that anytime you have a square root, if the value that's inside the square root is a negative number, then you get an imaginary solution, which is not a real solution. So what we would want to exclude from the domain in this particular instance is any values that I would substitute in for x that would make what's underneath the square root a negative number. So in terms of how you mathematically figure this out, all I'm going to do, and this is very similar to what we did with the fraction, I just want to take what's inside the square root, in this case it's just an x, and I want to make it greater than or equal to 0. And I would solve that if in fact there was anything to solve there. And the reason for that is because it's okay if x is 0, it's okay if x is a positive number, but what's not okay would be as if x were a negative number. And what you get when you solve something like this, and we'll talk about some examples of this in a minute, that would be what the domain of the function is. So just going over some different types of examples involving domain. So you have, for part A, right, you have a set of ordered pairs. And I think you guys are probably pretty familiar with this from some things that you've done in the past with ordered pairs. So the domain for this would be just the set of all x values. So that would be, remember, x values, that's the first coordinate of each of the points. So all I'm going to really do here is I'm just going to list the x values, negative 3, negative 1, 0, 2, and 4. So that's what the domain for part A would be. When I go to part B, notice that you have, let me resolve this here. Notice you have a function f of x equals 5x plus 2. And notice with this that since this right here, it's not a fraction with a variable in the denominator, and since it's not a square root with a variable inside it, the domain for this would just be all real numbers. So what that basically means is any number that I would pick for x, any number that's from negative infinity to positive infinity, if I substituted that number into here, it would get me some type of real value for y. So that's the domain for part B. But if you notice with part C, okay, we have g of x equals 1 over x plus 5. So now, because you have a fraction with a variable in the denominator, this right here, now the domain isn't just all real numbers anymore. Okay, so what we're looking to do here is we're looking to find a value for x that we would exclude from the domain. So in order to find what that value is, all I want to do is I want to take the entire denominator, x plus 5, and I want to make it not equal to 0, because I want the denominator to not be 0. Because if it were 0, that would make the function undefined. So to solve this right here, all I really want to do is just solve it like it were an equal sign. So I'm going to minus 5 on both sides, and I get this. X can't equal negative 5. So here's the thing. X could be anything else from negative infinity to positive infinity. As long as I don't put a negative 5 in here, I'll get some type of real answer for y when I do that. So the domain for this would be all real numbers except x can't equal negative 5. That's the domain for part C. So now if we go to part D, once again you have a function where the domain isn't just all real numbers. So we have the square root of 4 minus x squared. So if you take a look at this here, because we have this variable inside the square root, that's going to give us a domain that's not just all real numbers. So in order to figure out what value or values in this particular instance for x that are going to make the square root either 0 or a positive number, I just want to take what's inside the, I'm going to put this up here, I'm going to take what's inside the square root and I want to make it greater than or equal to 0. So I'm going to solve this just like it's an equation, but just keep in mind you have a greater than less than sign, and there's some different things that hopefully you remember from some things you did in algebra that are involved with the greater than less than sign in solving. So first thing I want to do here is I'm going to minus 4 on both sides, so I get negative x squared is greater than or equal to negative 4. And then remember there's a 1 in front of this x, so I'm going to divide both sides by negative 1. So just keep in mind when you do that, whenever you divide by a negative when you're working with a greater than less than sign, you actually have to change the direction of the greater than less than sign when you do that. So I get something like this here. I get x squared is less than or equal to positive 4. So what I'm looking for now, and I'm going to sort of stop the process of solving this and just kind of talk about philosophically what kind of numbers can I substitute in for x that's going to make this inequality true. So I think you guys can clearly see here that if I put a 2 in for x, okay, if I did 2 squared, right, that equals 4. So any number that I would substitute in for x that's going to be more than 2 is going to get me a value that's greater than 4. So in this particular instance, I can't substitute a number in for x that's bigger than 2. But another number that I could put in for x here would be negative 2. And if I squared negative 2, that would also equal 4. So if I were to put a number in for x that's less than negative 2, like negative 3 or negative 4, that would come out to be a value that would be, in this case, greater than 4. So just as we talked about up top here, I don't want to pick a number for x that's more than 2 because that would get me a value that's greater than 4. And similarly, I don't want to pick a value for x that's less than negative 2 because that would also get me a value when I square it that's greater than 4. So the values for x that would satisfy the domain here would be any number that's from, and this would be from and including negative 2 to positive 2. Meaning any number that I would pick that falls between those two numbers, including those numbers, would also be would also work here. So that's what the domain is for part D. And then for part E, it asks, or it gives you the formula for the volume of a sphere. And it has volume equals 4/3 pi r cubed. So hopefully you notice here that you have an equation where there is no variable in the denominator, and you also have an equation where there is no variable inside of a square root. So at face value for this, you may look at this and say that the domain for this is all real numbers. And because this is a problem where it gives you a formula in context, that's not necessarily the case. Because here's the thing. Whenever we're talking about radius, remember, radius always measures distance. So the volume of a sphere, distance must always be a positive number. So the domain for this, and this isn't really anything that I want to work out here, it's just basically saying that the radius must be a value that's greater than 0. You can't have a negative radius just because you can't have negative distance, and if the radius equaled 0, then there would be no sphere to even speak of for this. So the radius for this has to be a positive number, so the domain for this would just be that the radius has to be greater than 0. So that's just some different things that involve some examples of implied domain. Then the last thing I wanted to look at with you was this whole business of what's called a difference quotient. So the difference quotient is some different things that we're going to use with this. A lot of heavy-duty algebra that's involved with the difference quotient, and one of the things that just kind of setting the table for some things that you'll do in calculus next year, the difference quotient is involved in a lot of different formulas, particularly those that involve some different things with what are known as derivatives. So you have this right here. This is f of x plus h minus f of x over h. So remember what f of x plus h means to do. So what that means to do is I'm going to take the function that we have, and everywhere there's an x, I'm going to substitute an x plus h in its place. Then I'm going to subtract from that expression. I'm going to subtract the value of f of x, just the value of what the function is, and I'm going to divide the whole thing by h at the end. So let me show you one example of this. So you have this, f of x equals x squared minus 4x plus 7. So what I want to do with this is I want to break this into parts. So rather than trying to do the whole fraction at one time, I'm really just going to take this and just break it into some simpler parts here. So let me deal with just this part first, the f of x plus h. So if you have this, f of x, and this is x squared minus 4x plus 7. So if I were to do f of x plus h, all I want to do is I want to take an x plus h and I want to substitute it in here and here and do some simplifying when I substitute those in. So instead of saying x squared, I'm going to say x plus h squared. Got some foiling I'm going to need to do there. Minus 4 times x plus h plus 7. So with this right here, this is going to be x plus h times x plus h. Let me deal with this first. So when I FOIL this, right, I get x squared plus xh plus xh again plus h squared. And when I combine like terms here in the middle, I'm going to get x squared plus 2xh, or 2hx, I'll put the h first there, plus h squared. So that's what I get when I just do this part here. Then let me take a look at this. I'm going to distribute this negative 4 to the parentheses, and I'm just going to put this right on the end here. So negative 4 times x, this would be negative 4x. And then negative 4 times h, this would be negative 4h. And then I got plus 7 at the end. So that's what you get when you just do f of x plus h. So then what I want to do is I want to take that value, that x squared plus 2xh, or 2hx, plus h squared minus 4x minus 4h plus 7, and I want to subtract from that the value of f of x. So let me jump to another page here, kind of get a clean page going with this. So if I have this, x squared plus 2xh, 2hx, plus h squared minus 4x minus 4h plus 7. And what I'm going to do here, just to keep the two terms separated, I'm going to just put that in parentheses here. So this is going to be minus x squared minus 4x plus 7. So just keep this in mind with this right here, and I'm going to take you back to this here. This is all over h. This is all over h at the end. But what I want to do first, before I even start to talk about the denominator, let me simplify the numerator first. So yes, this right here, this is over h, but I'm going to deal with that sort of at the end of this. So what I want to do here is I want to take the terms that are in this first set of parentheses, this f of x plus h, and I want to just subtract it from the like terms that are in the second set of parentheses here, the f of x. So if you notice, I can do x squared minus x squared, and when I do that, they're going to cancel each other out. Then I also have this, negative 4x minus negative 4x. They're going to cancel each other out. And then I have this, positive 7, try that again, positive 7 minus positive 7. They're going to cancel each other out. It's kind of funny how that happens there. So if I take what I have left here, and I'm going to put this in descending order now, so I got h squared plus 2hx minus 4h. Hopefully you notice with this expression here in the numerator, they all have h's. So what I want to do next here, once again, I'm kind of disregarding the denominator here for a minute. You'll see why at the end. So I got an h I'm going to factor out. So this would be, if I factor an h out of h squared, that just becomes h. If I factor an h out of this right here, that's going to become plus 2x. And if I factor an h out of here, this is going to be minus 4. Now, let me put this whole thing over h. Right, just because recall that this right here, this whole thing is over h. So I'm saving the denominator here to the very, very end until I'm able to simplify the numerator and then factor an h out. So now I can cancel these out. And what I'm left with here is h plus 2x minus 4. That is the difference quotient here. So here's the thing. Nasty problem will definitely grant you that. But if you take a look at just the steps that are involved with this, or the skills that are involved with each one of the steps, you have some foiling that you're doing here first. Then you have some distributing that you're doing here next. Then you have some combining like terms that you're doing here. Then you have some factoring to do, and then some canceling that you can do at the end. So as far as the skills go that are involved with finding the difference quotient, it's a lot of heavy-duty algebra, and it's things that, to be honest, I've seen you guys do so far this year that I think you're actually pretty well versed in. So it's a lot of things to do, it's a lot of things to remember, but from a skill standpoint, it's a lot of things that I think you guys do, and you do it pretty well. So that basically takes care of some of the things that we're going to do here with functions. We're going to look next at some different things involving some other things with functions, vertical line tests, and things of that like.